And guys, welcome to lesson 7.6. We're going to talk about horizontal asymptotes and end behavior of rational functions. We started that last lesson, but that was only with a special kind of rational function. Now we're going to look at a broader case, a more general group of rational functions and how we can do it in general. So let's go ahead and begin here. I'm going to be sharing with you guys 3 useful facts throughout the day, and here's our first useful fact. This is actually just a review from our last lesson. Whether you go to positive infinity or negative infinity, what is the outcome of this particular limit? Well, yesterday we found out that that is going to be the k value. In this case, since there is no k, we would assume that it's 0. Okay, so make sure you have this written down in your notes. It's going to be helpful to have for the problems that we're doing today. So anytime you have a function that looks like this, and you're going to either positive infinity or negative infinity, the answer is going to be 0. Okay? And no, there won't be any k's on the problem today. They'll always be like this for the types that we're looking at today. Okay? So let's go ahead and take a look at example 1 here. Go ahead and write down this slide. Now I want to describe the end behavior of this function. So how do you do that? Well, you start by saying, okay, well, we have the limit as x approaches both positive infinity and as x approaches negative infinity. So we're going to do this problem twice, once for positive infinity, once for negative infinity, because we want to know what happens both on the right side and on the left side of the graph. Just going to put the function here. Now this doesn't look like the last slide, but it will in a moment. All right. So let's go ahead and start off with the top one. Now, something that we talked about back in Unit 6 was that when you're dealing with polynomials at infinity, the only term that really matters is the first term. So I really only care about the first term on the top and the first term on the bottom. Those are the ones that will ultimately determine what happens at the end of the function. So the limit of this function here is going to be equal to the limit of negative 3x over x cubed. They would actually have the same outcome because these other pieces here really don't even matter. They don't affect the end behavior. And so the first step is we're going to rewrite our limit without everything else, just the first 2 terms. The next thing we're going to do is we're going to reduce this. So let's reduce this expression here real quick. What does that become if we reduce it? Well, x to the first on the top, x to the third on the bottom. You would subtract your exponents, and since the bigger one's on the bottom, the result would go on the bottom. So here's what I have as a result, negative 3 over x squared. And now this problem does look like the last slide. It doesn't matter what number's on top. That doesn't affect anything. All that matters is that we have an x on the bottom with a power on it, or it may not have a power. It may just be the first power. It doesn't matter. But anytime you have a function that looks like this and you're going to infinity, well, the answer is going to be 0. So what that means is that this function on the right side of the graph goes to 0. Now you don't have to draw this, but I just want to show you. We don't have any idea what this looks like yet. We will later on in our unit, but let's just scribble. Okay, so that my graph looks like that, we'll say. But here's what I know. I know that on the right side of the graph, the y value reaches 0. So it goes like this. It approaches that x-axis. It gets flat up against the x-axis on the right side. Okay, so that describes what happens on the right end of my graph. Now, we're going to do the same thing for this one down here. This step would be the same. You would still only pay attention to the first terms. This step would be the same. You're still going to reduce it. And it doesn't matter whether it's positive infinity or negative infinity. So it also goes to 0 on the left side. So once again, even though I don't know what's happening with my graph, what it looks like here, I know that on the left side it's also going to go to 0. So this graph kind of looks like that. So, well, I mean, at least on the left and the right-hand sides it does. So that's how we're going to do it. So let's back up and review. Step 1, pay only attention to the first term. So, and I do want you guys to show your work like this for today at least. I want you to start by writing out the limit first. And then I want you to show that it's equal to this limit where we only look at the first terms. And then I want you to show that equals this limit where you have the expression reduced. And then you can put the answer. Okay, so I want to see those 4 steps. Now you don't have to show the 4 steps for the other one because they're going to be exactly the same. But you should technically write this at least and then put it equal to 0. Okay? So I'm going to let you guys try one of these. And really it's just an exercise in practicing the process of writing this out. Okay, so go ahead and pause the video here and give it a try. And when you unpause it, you'll see the solution. Okay, and there you go. Now this one actually had less steps because there was no need to reduce. Here's the original expression, so I'd want to see this written first. And then I want to see where you only pay attention to the first terms. And since we can't reduce, we're going to skip the third one, which is where you reduce, because this doesn't reduce. But regardless, we still have 1 over an x to a power. And anytime you have that, the limit at infinity is going to be 0. Okay. Same thing here. We're going to skip the steps, though, because the steps are exactly the same, so there's no need to be redundant. You still get the same answer, though. So they both equal 0. All right? Now let's move on to another type of problem. Here's useful fact number 2. So useful fact number 1 was that anytime you have 1 over x to a power, or actually it could be any number up here, by the way. It doesn't have to be 1. And we saw in the last example, you can actually have a number here. It doesn't matter. The point is, so long as you have a fraction where there's an x on the bottom, if you find the limit of this as x goes to either positive or negative infinity, it always equals 0. So that was our first fact. But let's go ahead and take a look at our next fact. This a just represents any old number. So for instance, suppose I was asking you to find the limit as x approaches infinity for 2. Well, what does that equal? Well, this is my function, 2. Okay, so if my function is 2, that means y equals 2. Now, let's think back to Unit 1, graphing linear functions. Do you guys remember what this graph looks like? What the graph of y equals 2 looks like? It looks like this. It's just a flat line. So you tell me, at the far right of my function, what would the y value be? No matter how far out to the right you go, the y value is always going to be 2. And so the answer is 2. And the same thing applies if you go to the left. The y value is always 2. So when you have a constant here, the limit, or at infinity or negative infinity, in other words, the end behavior, the y value is just going to be whatever that number is. Okay? And so in this case, if you have just a number here without any x's, then as x goes to the right or left forever, the answer is always just going to be whatever that number is. Okay, so that's our useful fact number 2 that we're going to look at for today. So let's see how that one comes into play for us. Let's take a look at example 2. Go ahead and write this one down. All right, so once again, I want to describe my end behavior, which is infinity here and negative infinity also. I want to go to positive infinity and negative infinity. And I'm going to put my function next to both of these now. So that's step 1, is to write this out. And this is how we describe the end behavior. All right. So step 1 is the same. You're still going to rewrite the limit where you only have the first 2 terms. So it's going to be x squared over negative 3x squared. Okay, and then we're going to reduce. Now in this case, the x squareds cancel out completely, leaving me with nothing on the top. So but that nothing is really something, right? It's a 1. So we're going to have a 1 on the top now over -3. Now notice how after I reduce this one, it's just a number. And whenever you're taking the limit of a number at infinity, the answer is going to be just that number. There you go. The same steps are going to apply once again to this guy. All the way through, you're going to end up getting -1/3. Okay? Now let's talk about what this means then. Okay? And actually, I probably should have been a little more clear on this in the last example, but we'll start doing it now. I want you guys to understand these represent the horizontal asymptotes of your function. On the last problem, I would go back and circle the zeros that we had. Go back to those last two problems that we did, circle and put horizontal asymptotes, because that's what they are. Let me explain why. Because, once again, I don't know what this graph looks like. Okay, so blah, 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 blah. But I do know that at the far right end of my graph, the y value reaches 1/3. So, like, let's say this is 1 right here. 1/3 would be like right here. So, I'm going to draw a horizontal asymptote. And I know that at the far right end of my graph, my function, my y value wants to reach 1/3. And the same thing happens on the left side. It wants to reach 1/3. Okay? So basically, what this when you're finding end behavior of rational functions, it tells you what the horizontal asymptote is. So once again, I'm going to ask you guys, you should probably go back. I made a mistake on examples 1 and student practice 1. Please go back and circle those zeros that we had and label those as horizontal asymptotes because that's what they are. Okay? I forgot to mention that. All right, let's go ahead and have you guys try one like this. So go ahead and pause the video here and write out your solution to this one. And when you unpause the video, you will see the solution. Okay, there you go. And this time I decided to kind of go ahead and show my work for the bottom one, although I don't really need to do that. But the reason I decided to do it this time is because on the next type of problem we're looking at, we actually do need to show work on both of them. But for these first two types, we don't. Okay? So let's go ahead and move on to our last interesting fact here. Fact number 3. Now this is something that we learned back in Unit 6, the end behavior of polynomials. Polynomials don't have horizontal asymptotes, so they either go up or down infinitely far, so we end up getting infinities. Okay, so let's go ahead and review what we learned in Unit 6. So we learned that when this is positive and this is even, the graph goes up on both sides. And so on the right side, which is represented by this, the graph, the function goes up into positive infinity. But on the left side, it also goes up into positive infinity. Because remember, this means left, this means right. And both of these, since they're positive, mean up. So the y value means up or down, the output means up or down, and the part next to the x tells you whether you're on the left or the right side of the graph. Now let's take a look at the other one. Another situation was if the a was negative, but the n was even. In that case, what we had was down on both sides of the graph. So if we were on the left side, the graph went down, and if we were on the right side, the graph also went down. Okay? If n was odd and a was positive, it looked like this. So in this case, on the right side of my graph, it would go up, positive infinity. And on the left side of my graph, it would go down. And then finally, in this last box, we had up on the left, down on the right. And so for this one, on the right side of my graph, it goes down, negative infinity, since it's down. And then on the left side of my graph, it would go up. Okay? And just as a reminder, okay, when you're doing these, in case you didn't catch it already as I was speaking, if you have positive infinity here, that means right side of your graph. If you have negative infinity, that means the left side of your graph. And over here, a positive infinity means up, and a negative infinity means down. Okay? So that's kind of the idea there. So if that's helpful for you to write that little note on the side, you might want to. All right. So let's go ahead and put this useful fact into practice for us here. All right. So this one is, and these particular problems are a little bit different now. In two ways I can think of. One way that they're different is, so far every time we've done this, you really didn't need to do the bottom one because the answer was the same. But for these problems, a lot of times the bottom one won't be the same. So you have to be careful. We actually need to do both the right side and the left side separately. A lot of the process, a lot of the steps you take will be the same, but the last step may not be. So I'll show you what I mean. Okay, so let's begin. So once again, the first thing we're going to do is we're going to rewrite the limit, where we just include the first term from the top and the first term from the bottom. And the next step is the same as well. We're just going to reduce this fraction. So if I reduce this, I end up getting x over 4. Now it might help you guys to know that when you have a variable on top like that, a way that you can rewrite it is like this. You don't have to do that if you don't want to, but they do mean the same thing. Now what's the point of all that? Well, I have a positive coefficient now, and I've got an odd power. And when you have a positive coefficient and an odd power, that means it's up on the right, down on the left. Okay? And so, since we're on the right for this particular problem, then it's going up, and therefore my answer will be infinity. Okay? Now, all these steps here will still be the same, so we really don't need to do any of these steps here again, but the answer is actually going to be different. Because for this one, since we're on the left, you guys might want to color code this like I am on your notes. Since we're on the left, that's talking about this side. And therefore, as you guys can see on this side, it's going down. Now, so that's one difference. So one difference with these types of problems where you end up with something that looks like this, a coefficient next to a variable with an exponent. One difference is the fact that you actually could, not always, but you could end up getting different answers for the top and the bottom. Okay. Now the other difference is this. Since this is not a number, that means this graph has no horizontal asymptote. Okay? In other words, if you guys were to try to graph this thing, which we will later, but for now, once again, we don't know what this function looks like. And so far today, what we've seen is that they always end up getting flat on one end up against a specific number. But in this case, that's not true. On the right side, it just goes up, and on the left side, it just goes down. And so this one doesn't have a horizontal asymptote. It doesn't have a y value that it's approaching. It just keeps getting higher and higher on one side and or lower and lower on another. Okay? So, once again, what are the two differences with this situation? One is that the right and the left-handed limits may be different. So far, on the other cases today, they've always been the same, but now they are different. And another situation is that when you have infinities, that means there is no horizontal asymptote. Okay? So let's see how you guys do with one of these. I'll throw one at you. Go ahead and pause the video here and give it a try and see how you do. And when you unpause the video, you'll see the solution. All right, guys, so here's our answers. Just study that for a second, and we'll explain it to you. So, first of all, we end up with a situation where we have a negative coefficient with an odd power. And when you have a negative coefficient with an odd power, it's going to end up being down on the right and up on the left. So that's what our end behavior looks like. And now we need to describe it with our limit notation. So since we're on the right side, that would be this one. And on the right side, it goes down. So therefore, the answer to this one is negative infinity. And then for this one, on the left side, we're going up. And therefore, this answer is positive infinity. Okay? And so that describes the end behavior. And once again, this means that there are no horizontal asymptotes. All right. So now, we've looked at 3 different types of situations today. We've looked at situations that end up giving us this. When we have that, the answer is 0. Okay? And when that's going to happen, that's usually what happens anytime, well, that is what happens when the power on the top is less than the power on the bottom. You're always going to end up with some kind of a situation where you might have a number here, you might have a number here, but you're always going to end up with an x in the bottom and a number, and the limit at infinity is always going to be 0. It's the same on the left as it is on the right, and that's your horizontal asymptote. Okay? Another situation that we've looked at is this situation where you just have a number. And in those cases, the answer is that number. That happens anytime the power on the top is exactly the same as the power on the bottom. Because in those cases, they're just going to go away, leaving you with this number here and this number here. And that will end up being your answer for the end behavior, which is your horizontal asymptote. And then finally, we looked at this last situation, which is where you end up with something that looks like this. And in that case, you're going to need to remember your end behavior for polynomials and how to tell whether it's positive infinity or negative infinity. Okay? And so that happens anytime the power on the top is bigger than the power on the bottom. So here's some mixed practice for you guys to try out putting everything that we just learned together. There's a mixture of various types of problems here. So I want you guys to see if you could describe the end behavior of all 4 of these. Go ahead and pause the video, and when you're done, you will see the solution posted. Okay, so this time I didn't show all my work, but I will discuss what I've got here a little bit. So if you just look at the first terms and reduce it, all you're going to be left with is 2, and when you have a number there, that's the outcome, and that's a horizontal asymptote. For number 2, taking the first terms, you end up with 1 if you reduce that, and once again, same outcome. When you have a number there, that's your horizontal asymptote. It's the same on the left and the right. Number 3, same thing happened once again. When you reduce this, you end up with 1/3 because the x's go away, leaving a 1 on the top. And so you have another horizontal asymptote of 1/3. And then finally over here, when you reduce these, you don't get the same kind of an outcome. In this case, you actually end up with 1/3 x, and that's a polynomial situation. So that's where you would have to use your chart. And when you have this, it's up on the right and down on the left. And so for this, on the right side, we put positive infinity, and for the left side, we put negative infinity. Okay. Now I want to share with you guys a shortcut. Okay. So if you're ever trying to find the limit of a rational expression at either infinity or negative infinity, then we can actually have a little bit of a shortcut here. And it's all based on what's going on with these powers. If the power on the top is less than the power on the bottom, then the answer is going to be 0, whether you are going to the positive infinity or negative infinity, whether you're on the left side or the right side. If the power on the top is equal to the power on the bottom, then the answer is going to be whatever these coefficients are made into a fraction of each other, a over b. Okay? And then finally, if you're dealing with a situation where the top power is greater than the bottom power, there is no shortcut. You kind of got to do it the way that we learned it initially. So I want to demonstrate the shortcut to you. You don't necessarily have to write these problems down, but I just want to prove to you how it can make things go a lot faster. All right, so once again, you guys don't need to write this down. Okay, I just want to demonstrate it to you real quick, how the shortcut can make things a lot easier. Notice how the power on the top and the power on the bottom are exactly the same. When that happens, the answer is going to be whatever the coefficient is on the top over the coefficient on the bottom. So both of these are going to have an answer of 1/2. And that's a horizontal asymptote. Okay? So that's much faster, as you guys can see. Let's take a look at another one here. All right, so notice that there is no power on the top and that there is a power on the bottom. Well, that would indicate that the power on the top is less than the power on the bottom. And when that happens, the answer is 0. And once again, that would be my horizontal asymptote. Okay? So that's much, much faster. Much faster. All right? So on this one, the powers on the top and bottom are the same. So it's going to be -1/1, which is -1. And that would be my horizontal asymptote. All right? Let's look at one more example. All right. Let's take a look at one more here. Now, in this case, the power on the top is bigger than the power on the bottom. And when that happens, there really is no shortcut for that one. We actually kind of have to go through the whole process. Okay? So you're going to take these two terms here, and you're going to make a fraction out of those. Right? And then you're going to reduce it. And that leaves me with -1/3 x squared. And when you have a negative coefficient and an even power, it's down on the left and down on the right. And so for both of these, it's going to be -infinity because it's down on both sides. Okay, so that one's the only one where there's really not a nice shortcut. But the other two, you can jump straight to the answer. Okay? All right, and that'll do it for our lesson for the day. And I'll wish you guys a good day, and we'll see you next time.